don't remember. They was talking about space technology, and I think AU is using that in a good way. So those kind of things you will have to upskill, so that when you go into the market, you are not just telling that I am a mechanical engineer, I know technology. I think AU is, and I know the concepts of mechanical engineering, finite element methods, and so on and so forth. But can you use those technology with the help of digital technologies? If the answer to that is no, then your job may go, because there's somebody else there who is also a mechanical engineer, but who knows, who is AI literate. And if there are two people, one who's not AI literate and the other one who's AI literate, whom will a company hire? Obviously, somebody who's AI literate. So times are changing. We need to change with times. That's my answer to your question. Does that help? That's why the answer which I'm giving is not just for students, it's also for the faculty members and curriculum developers to include these technologies and make your graduates AI skilled, AI literate, industry ready, and so on. Okay, because if you don't do that, then you are doing a disservice for them. You are not making them industry ready.
Further questions we'll take in the later sessions. Thank you, sir, for sharing your valuable expertise on artificial intelligence. I request everyone to give a long applause for the session.
Thank you. Thank you very much.
So please.
Yes, yes. I think I'll give this to them. Okay, sure. Start right now.
Hereby we insist all the attendees to carry on with the further proceedings of the conference.
Have a list of papers in this session?
Yes, sir.
Or maybe if you can, I can have it. Yeah. Sure.
Students can leave for the lunch break.
Maybe you could ask them. Ask them.
Please proceed silently. Everyone, all students, please proceed to classrooms silently.
You have to present this here, it's also-
Thank you, dear students. You can leave for lunch break now. And thank you for listening patiently and silently. Thank you.
From water resources. Oh, yeah, from water resources. So nice. I've been meeting mechanical engineers, computer science.
Yeah.
Good to meet a water resource person.
Actually,
Sir.
my research was groundwater hydrology.
Oh, groundwater.
We have not used this AI technologies.
Ah. I use many years back, little bit groundwater. Yes. You know Shashi Mathur from IIT Delhi? Shashi Mathur?
No, sir.
No. Okay.
I know IIT Mumbai, Eldo, sir.
Eldo, sir, you know. Okay, okay. Yeah, I know him. Eldo, yes.
I request all the faculty to occupy the front rows and presenters.
Oh, I can start from there. Let me know when to start. Are we going to start now?
Yes.
Okay. So the first speaker.
We are going
Okay.
to
We'll start.
We are going to start.
Yeah. Madam, you have any announcements or should I?
I have an announcement.
Okay.
I will just call on.
Sure.
I would like to extend a special invitation to the esteemed authors whose exceptional contributions have enriched our conference. Your research and insights from the corners form the cornerstone of our discussions and represent the spirit of progress and collaboration that the platform stands for. We are privileged to have distinguished minds among us, and it is my pleasure to invite Mr. Banamurthy to present their paper titled Novel System for Material Handling Using Automation Studio, a Design Thinking Approach. So please come on to the dais.
Yes, yes. Just a small announcement for the speaker. You got 10 minutes to present your work and 5 minutes for question and answer. So total 15 minutes. And once you have finished 8 minutes, Dr. Vishwanath will give you a warning that 8 minutes is over and you got 2 more minutes. So please try to finish your talk within those 2 minutes so that we are within the time limit. Okay. Thank you.
Evaluation takes
Okay.
just few seconds.
Okay, sure. No problem.
Based on what we'll announce the question paper.
Okay, sure. Sure.
There are some guidelines to match the rubrics.
Yeah. So, yeah, sure, sure. Sure. Sir, help us, sir. You have ready? So I know. If you don't have a hard copy, just send it on WhatsApp.
Ah, yes, sir. On है भैया
Oh, okay.
भानुमूर्ति VNR Vijay. Thank you. Yeah, please.
Next paper will be by Irfan Sadak sir. Please be ready. Third paper will be by M. Sandeep sir. Please be ready. Yes.
ఎట్లా అయిందా ఓకే నేను రెడీ ఓకే పాయింట్ ఓకే Yeah. Good afternoon, everyone. Good afternoon, Dr. Nitin sir. Thank you so much for your session. And it is directly like connected to my title here. So let's get into the title. So paper ID is 25 and myself I am Mr. Bhanumurthy, Assistant Professor, VNR VJIT, Mechanical Department. And the title is all about like novel system for material handling using automation studio, a design thinking approach. Here I just wanted to get into some basic information like being a mechanical engineer and just now like sir told that There are AI, but it is not applicable totally for AI to take over mechanical or a core departments. So, in line with the same topic, as AI in everything, but not in mechanical. In mechanical, I should be there. I, what is I? It is we who has to work for the mechanisms. Ultimately, once if at all you design a mechanism for basic minimum things, so minimum contribution should be there from the mechanical engineer in order to design a product. So when you wanted to design a product, obviously, like not directly getting back from the engineering aspects, we need to go with an design thinking approach. What is this design thinking approach? So design thinking approach is nothing but it is an passion where you are getting into the user needs and you wanted to find out whether it is feasible, viable, and desirable or not. These three aspects are very important in order to design a product. So this is the work where I have explored into novel systems for material handling using automation studio. Material handling, as in the image you can see, it is a basic work where a mechanical person or a human being, a layman is been working, but what is the mechanical engineering contribution can go with this. So this is the idea and this is the work. So this is a team which we have worked on it. These are the contents: introduction, problem formulation, methodology, simulation, optimization, results and discussion, and followed by the conclusion. So getting into this, as automation is the era where we are in, no doubt about it. So core departments, what we are doing and what is our contribution to the society. This is the aspects which an engineer, each and every engineer has to question themselves. Then definitely we are here to solve the problems in the society. So whatever we are doing, obviously the output should be and the conclusion is in order to serve the society. So this is my project is going to serve the society and it will be helpful by using automation. Again, it leads to AI. So let us see what exactly it is all about. So the field of robot applications, the concept we took is the robot applications has significantly advanced over last 20 years. We know that. So a robot is a mechanical device that carries out automatic actions and motions under the direct supervision of a human being. Obviously, so any automation is nothing but it is a logic system. It is logic system from the minds of a human being, no doubt. So the only thing is that right path, how you are going to give or develop a logic, either logic in the form of a PLCs or in the form of an algorithm. So the coding system which you wanted to give, there are different methods, different means where we can develop any system into automation. But which one you are using is important, because the end of the day, the thing is that whether it is feasible or not. Feasible in what? Feasible in the sense of engineering aspects as well as along with the economically also. So these two things are important. And finally, obviously, as I told you, desirability. Whether you have a technology and you have feasibility, but if it is not desirable to the person, then ultimately the product is waste. So all these three things have to go together. Then only the output will be useful for the end users. So robots are crucial components in automating and flexible production systems. As we've been seeing in the production lines, all the production lines are being automated, but what type of mechanism is being used and in advance. Now as being we are into an AI era, so what is the advances and whether it is a feasible, whether it is economical or not, we have to question ourselves and we have to go into it. So this is a basic thing, articulated robot. So this is the basic thing where I wanted to show you the showcase of this. So this is the thing we have considered and we have designed our project. So this is an articulated arm. I don't know how far the people they know about articulated arm. The basic introduction I just wanted to give you. And this is a base. We have three different types of joints and all the joints are rotary joints. So rotary joints and prismatic joints, these are the two different joints we use in robotics. Based upon the application, which type of joint is being used, we will decide it. The person will be deciding it. Formula, problem formulation is, so this is how we have been. So to design pneumatic manipulator, we call it as a manipulator robot. Ultimately, it is nothing but called as an manipulator. To develop an Arduino programming, we have gone with an Arduino programming, and to integrate hardware and software here to test the system. These are the four different objectives which we have designed it. We have designed it by using design thinking approach. So in design thinking approach, there are four important parameters we need to consider for designing a prototype. So what are the four? Let me go with this. First one is empathy. Empathy, to whom you are going to go? Empathy, we are going to take it with from the stakeholders. Who are the stakeholders? So stakeholders are end users, creators, in between the marketing people, all these things people are comes under the uh, stakeholders, where we go on with empathy. And after that, next one is defining the problem. After having an empathy, because based upon, see, we can have here in our auditorium we have 20 plus students and faculty are here. Each and every perspective is different. We have to collect all the information. We need to collect all the information. After collecting the information, the person should go with the brainstorming, and having all the brainstorming and all, which one is appropriate. We have to come up with those things, and we'll define the problem. And after having a defining the problem, next thing is that we need to go with an ideation tools. So ideation tools are different mechanisms we combine together to have an best output with economical. And after that, prototype. After that, having a prototype and testing these things. So this is the methodology which I have followed. CAD modeling. CAD modeling is being done by using many literatures and developing of electro-pneumatic circuit. Yes, electro-pneumatic circuit. The thing is that we have robots. Robots are being driven with the different drive systems. So different drive systems, and here, as I am talking about the feasibility and economic, so I wanted to go with the least possible thing with high efficiency. So this is what I took, and in this, the three different drive systems I wanted to just give you an idea. Oh, thank you. Okay. So drive systems are of hydraulic, pneumatic, and electrical drive systems. So these three, among them, I have gone with the pneumatic drive systems and circuit design and hardware components. After choosing the pneumatic drive system I have chosen is because it is economical. It is freely available. The air, normal environmental air, which we get it, and we can do it. And we development of C programming, integration of hardware and software, conclusions and testing of the systems. So these are the CAD models. These are the CAD models. These four A, B, C, D are the jaw, hitch joint connecting links and supporting links of individual parts, and it is a gripper assembly of the three jaw end effector where we have took, and this is the model of an robot arm, the base, and this is assembly of an end effector and robotic arm with the different parts we have located here, and this is the drive systems simulation part. Developing it and then hardware directly will lead to maybe a fatal error. So in order to avoid all those things, we go with these software systems. So in this, cylinder 1, cylinder 2, cylinder 3, cylinder 4 and cylinder 5 all are double acting cylinders. Double acting cylinders used by 5 by 2 DCVs. 5 by 2 DCVs are used to control the particular action. Okay. So these are the different calculations, design calculations which we have considered in order to develop the robot. So these are the circuit signals, the output signals, how it extends. The end effector, cylinder A. As I told you, I am talking about the cylinders here. Let me go back there. Yeah. The extension. Sorry. So individual system cylinders are there. Individual cylinders are being operated by using the control systems. Power mode lo better. Presentation mode lo better. Yeah. Right. Yeah. Okay. Yes. As I was talking about the cylinders, each and every cylinder are being linked here. Wanted to show you in the in our prototype which we have developed. This is a ultimate prototype. Here you can see a cylinder 1, cylinder 2, this is cylinder 2, and here three different cylinders which have been used for the jaw in order to hold the workpiece there. Yeah, this is how the functions, and this is the programming, all the things. And these are the relays, different relays, how the relays are being actuated when you wanted to open and close off the grippers and all. This is the logic behind the working of the robot. Yeah, and this is the time frame extension and all. Time frame for cylinder and its strokes. These are the graphical representation of advancing and retraction of the each and every individual cylinders. This is a prototype, and we have even applied for the patent also. It is under process. So the patent is going on this. And the conclusions, coming to the conclusions, pick and place arm of material handling in inline manufacturing is been modeled, it has been done, and the major thing is that what we have observed is, so it is taking minimum cycle time of 30 seconds by 5 bar pressures, and in order to pick the brick from one place to another place based upon the requirement. So these are the different references which we have come across with. Thank you, sir.
A few minutes for questions.
Have 3 minutes.
Yeah, please. Mhm. As I was talking about the jaw, here we have three jaw gripper. We have considered three jaw gripper. You can see in this picture, you can see it clear. One, two, three. Three jaws. In order to operate the three jaws individually, if at all we have four jaws, we would have taken four cylinders there. That is the only reason. Yes.
Brick.
Uh,
One jaw also.
it can be done. It can be done, but the amount of pressure. But when you are talking about the pneumatics, you have a limitation of the pressure there. So in order to have those things, we have come up with this. Automation today software. Thank you. It is available in our college. It is a paid, not open source, ma'am. Really, sir, because one of my student, as I told you, I'm faculty and the student, his parent is into construction field, and he's been observing his parent from the childhood that the people they are being like, as we know, it is a tedious work, obviously, and whatever the effectiveness and productivity we have in the early morning hours, in the first hour, the same will not be continued throughout the work hours. So in order to maintain those things, because he is a contractor, he wants the productivity. Obviously, he try to go with the productivity. So if at all it is a manipulator, we can adjust the manipulator height and all, and we can even work for 24/7 with the same productivity. So that is the output which we got. So it can like it is based upon the limitations, ma'am. We have limited the arm length, but whatever the arm length we wanted, we can have it. It is purely depend upon the requirement. From part A to part B, where you wanted to pick this and place it, so you can. Thank you, everyone. Thank you, the organizing team.
Thank you, sir. I wish to announce that we are excited to announce that we are going to present awards for the best paper presented. So I request all the presenters to be attending the sessions for today and tomorrow. Thank you. Now I request S. Irfan Sadak sir to present his paper on exploration of angle of attack on the functioning of airfoil profile blade using numerical approach.
PPT. దానికి PPT డాట్ PPT ఫైల్ దాకా వచ్చేసింది అది. మీరు open చేసి- డాట్ PPT డాట్ PPT ఎక్స్పర్ట్. If it is mic, it is. I'm not comfortable with this. Okay. Good afternoon, all. Good afternoon to dignitaries and authors from various institutions and students as well as faculties of Anorak University. Good afternoon, all. Today I'm going to present a paper on exploration of angle of attack on the functioning of aerofoil profile blade using numerical approach. Numerical approach here, I used CFD analysis to perform the numerical approach here. In this particular process, so this is the abstract. The efficacy of the aerofoil is determined by lift to drag ratio. As lift to drag ratio increase, the competence of aerofoil increases and vice versa. Here in this particular process, I used NACA 4406 aerofoil profile blade with various angle of attacks likely to be 2 degrees, 4 degrees, 6 degrees, and 8 degrees, and a velocity of 2 meter to 15 meter per second at an altitude of 17.4, which is located at Banjara Hills in our college. Okay. So first I have performed numerical analysis, then the work is carried again to be carried out in experimentally in that particular latitude location. CFD analysis is performed. Here in the CFD analysis, a domain is created. The input parameters are given as a velocity, 2 meter to 15 meter per second, and angle of attack, and outcome is we got 4 degrees and 6 degrees are the optimum angle of attack, where the performance of the turbine blade of 4406 is to be optimum and have the efficiency of about 30%, considering the bits limit factor. Introduction, I utilized a NACA series. What is that? National Advisory Committee for Aeronautics Aerofoil Profile Blades. And here NACA 4406, what is that 4406? And an example here is 4406. The first digit is your maximum camber, that is given here, maximum camber height. This is the camber, first digit, second digit, and the second digit is 4, the 40%, and third digit is the total thickness of your the aerofoil profile blades. Okay. Using these nomenclatures, we designed various profiles. These profiles are taken from the image courtesy, the manuals of NACA manuals, and the coordinates for the present work 4406 are taken from the NACA manual and modeled in SolidWorks, imported in ANSYS, that is CFD analysis. A domain is created. So let me go for the literature. This is the angle of attack. What is the lift force and drag force? Literature survey, in previous literature, they have performed on 4420, ranging from 5 to 20 meter per second for angle of attack 0 to 20. So outcome they got the angle of attack 6 for that 4420 profile at an average velocity of 20 meter per second. And for profile 4412, again they have performed angle of attack ranging from 0 to 12, and optimum angle of attack was 8 degrees Celsius. And thereafter, the L by D ratio declines. In this literature, low wind speed with Reynolds number 2,32,940, NACA 0015 profile, 17 meter per second, and angle of attack 0, 5, 10, and 15 degrees. So they got the good results in 15 degrees angle of attack. And in the similar way, the same profile, NACA 005, with a low Reynolds number, again they got 16 degrees of angle of attack. So there is a 1 degree higher speed and a lower speed, they got 1 degree difference. So the objective of my work is to evaluate the aerodynamic features of vertical axis wind turbine at a latitude of 17.41 degrees, with an emphasis on assessing the effectiveness of the NACA 4406 blade by adjusting the angle of attack, that is 2 degrees, 4 degrees, 6 degrees, and 8 degrees. So modeling is taken from the NACA standards, and analysis is performed. See here, this is the CFD analysis process. First, the domain is created. So lighting. So this domain is created. NACA 4406 profile is created. A domain is created, and the solid model is removed from the domain. This is inlet velocity. We are giving inlet velocity, outside velocity, and these two are considered as the walls. So, and taking K epsilon method and giving the input velocity, the material is aluminum material. So, solving that for 2 meter per second, 4 meter per second, and 8 meter per second, we gave the velocity as a 2 meter per second. The output velocity is another 2.37. That is 0.37 increase in the velocity. That increase in the velocity we are assuming as a rotor velocity for calculating the power. So from that results and discussion, we can see the lift and drag forces for various angle of attack 2, 4, and 6. If you perform individually, lift for higher the angle of attack, higher will be the lift and the drag. So angle of attack, we see, so 8 angle of attack has the higher lift and higher drag. But when the ratios are made, L by D ratios, that is lift to drag ratio, the angle of attack is changed from 4 to 8. Sorry, 8 to 4. One second. So now when L by D ratio, it is angle of attack is the 4 optimum angle. L by D ratio first increase with velocity, peaks before stabilizing or slightly decreasing. Angle of attack 4 has highest L by D ratio, followed with angle of attack 2, 6, and 8. So when considering the lift force or drag force, the angle of attack is 4. And considering that rotor speeds, the increase in the speeds, what we attained during the analysis, are used for calculating the power using theoretical equations. And in this particular figure, we can see the velocities, velocity versus with the torque, and velocity with the RPM. These RPM we are considered to perform the, to calculate the power analysis. Power is equal to half rho A V cube. And from that, we got the power output at an efficiency of the turbine blade is 30%, and which the same findings has been observed in reference number 16. So for when we calculated these, the velocity of the wind rotor speed, we got angle of attack 6 is the highest one. For power calculations, the RPM, the speed, angle of attack is the 6. Okay, sir. It is next conclusion. Next. So, concluding optimum angle for L by D ratios when we are considering the lift force to the drag force ratio, the force consideration, the angle of attack is 4, and when we are considering the power, the angle of attack is 6. So, I conclude that for NACA 4406 profile aerofoil profile blade, these two are the optimum angle where we can get the turbine efficiency to be 30% when considering the bits limit factor, which is 0.593%. This observation is crucial because to emphasize the importance of maintaining a harmonious equilibrium among lift and drag at this vintage point in order to maximize power output. The motivation over this particular project work is to develop an alternative renewable energy source to overcome this traditional energy to the non-conventional energy, so that is renewable energy sources. That is the point we have chosen that particular project, and various literature has been carried out, work has been carried out, but limited work is carried in that particular latitude location. Okay. These are the references. Any queries? So alternate even angles I have considered. We can consider from 0 to 20, but a majority of the literatures are lying, the optimum angles are from 5 to 8 degrees. They are considering from 0 to 20 based on the profiles. 0015 profile having for larger Reynolds number it is 15 degrees and lower Reynolds number it is 16. When we go for the 4 series, the angle of attack is between 2 and 8. So maximum in the literature number 16, they got 6 as an angle of attack. So I have increased the angle of attack. So why not 8? So even in my analysis also it is proved that the 6 is the optimum angle for power calculation when we are considering. I have not continued. We can continue from 0 to 20. We can take any of angle of attack, but I optimize there itself. CFD analysis. CFD analysis. No, actual analysis has to be taken out. We have a low speed wind turbine in our college. We have to. Sir? It is a vertical axis wind turbine. No, three-bladed vertical axis, not Darius. Three-bladed vertical axis wind turbine. Darius or 7 they have some certain profiles. I am taking H type vertical axis wind turbine. Yeah, CP, yes. Maximum, yes. This is a simulation work. There may be variation between experimentation values and the simulation values. Yeah, 30%. 30%. Yes. Yeah, before to identify which type of angle of attack. So directly we cannot go with a different angle of attacks in experimentations. L by D ratios are the output parameters we are considering, and we have taken RPM after that. With that RPM, we are considering using that RPM value in equations, we got the power, not L by D ratios. With that, to that L by D ratio, this is the RPM what we attained. RPM values for L by D force, lift force to drag force, we are assuming 4 angle of attack, and for these RPM 6 angle of attack. And RPM we have taken RPM for calculating the theoretical calculations, and output is taken from there. Yeah. Yeah, this is an example to say what is actually 2421. What is the nomenclature? I have worked in 4406 to represent what is 4, what is 4, what is 06. Here I have given 24 is an example.
Go to your abstract once. Next. Next, sir. Okay, that's an example that you mentioned.
Example 2421.
Why 4 series? Specifically, why 4 series?
The
4,
literature they have done 4412, 4420, 4412. So I have taken 4406 profile. Not why. The literature has not been, limited literature is carried in this profile 4406.
There is no research available.
Limited research. Not, I cannot tell that it is a no literature.
You compared with that literature?
Yeah, that
For
16 literature.
4406?
Yeah, yeah.
For 4406?
Not 4406. Other angle of attacks.
Okay.
I could not find 4406 more work based on that.
Okay. Thank you.
Speed. No, speed. For different angle of attack, speeds. First, L by D ratios, to study the efficiency or effectiveness of the turbine blade or the turbine, we need to study first L by D ratios. Higher the L by D ratio, higher will be the efficiency. So for that case, we have studied L by D ratio. Thereafter, again same considering the angle of attack, the power has been calculated. For simulation work, we can just to study L by D ratios, we can stop at an angle of attack 4. Further, to study the efficiency, if these kind of profiles are used experimentally, so what could be the power output? For that study, we have done this analysis. Thank you.
Thank you, sir. Now I invite M. Sandeep Kumar, sir, to present his paper on analysis of missile wing stability and weight reduction through composite materials and ply optimization.
A very good afternoon. A very good afternoon to all the dignitaries, faculty members, and student friends. I'm here to present a paper title, as mentioned here, and it's a work of one of my student who has done it in DRDO, and under their supervisions they have done it. I am here to just showcase you what kind of work they are carrying out, and just let me give a brief. A missile wing, everyone knows it. We do it with a metal or aluminum material. Just our student was there who wanted to do it, or he was given a task to do it on a composite, right, and to analyze it. So he didn't had an hands-on experience, and with the limited period of time, he did simulations and answers, right, by taking the model. Just yeah, sorry, yeah, thank you. It's not audible. Yeah. So, as our previous friend also like mentioned, yes, most of the aerofoil profiles have standards, and here NACO 4, the missile wing which was there was modeled using NACO 4 data points, and here what we had done it. We had GFRPs and carbon fiber reinforced or CFRPs composites. Two composites were considered, and the results were compared with aluminum one, which is being generally used like AL 2014 material. And if you see, as it was a student project, there were many, the simulation was done in many steps, varying the various thicknesses, the ply orientations, and to give a clear idea how to really go from a top down approach. Right. So the ply orientation and the composite layup, sorry. So the ply orientation, the composite layup was done with ACP, and statistic structural analysis was performed to identify the deflections, and they have tried to see that how they could reduce the thickness of the ply with various ply orientations. So the buckling analysis is also carried out for different orientations, and the reduction was mass was observed in the wing from 61 to 61.7% using E-glass and 72.3% using carbon epoxy. Right. So coming to the material properties that they have considered for E-glass and carbon epoxy are as shown in the table. Now coming to the ANSYS modeling, initially the model was done in APDL to come down to, actually the initial thickness of the ply was taken around 10 mm and they came down to around 1.5, 2.5 mm. Initial studies were done with APT and then the ANSYS workbench. So the entire structure was converted into a shell model and then the same procedure, general procedure was maintained there. Now coming to the ANSYS stiffness wing with APDL. So here if you see the performance was done with 10 mm thickness, as I mentioned. The thickness of the ply was 10 mm. And the other thing what they are done is in APDL, initially the model which was there with stiffness and the top plate and the bottom plate with stiffness, it was considered as a single model. All right, the whole was a single model. So if you see, the higher mass was considered. So the results showed that the higher deflection than the standard due to the higher mass of the wing structure. The higher mass is due to the fact that the stiffness are gaining more thickness than the actual required thickness due to the excess ply layup on the stiffness. So that was the condition when was observed when they did with APDL initial studies with 10 mm thicknesses. Then what they did is giving the different thicknesses to the stiffeners and the outer shell was a bigger a bit of an issue. So what they did is like they overcome the problem as the model was created with stiffeners and the stiffeners was considered separately. The model was created with stiffness and rest of the wing as separate surfaces so that they could change the thicknesses independently, the stiffness and the outer ply thicknesses. So the ply orientation were taken on the based on the previous APDL results, and the stiffeners were given a thickness of 1.5 millimeter as per the design and 4 millimeter thickness for the rest of the surfaces. So with this result, the static structure analysis, the deflection was in the wing was shown as 18.33 millimeter. Further, what they did is they created 4 separate entities. The 4 individual components are stiffeners, top and bottom surfaces, root thickness, and root thickness for longer side and the shorter side of the wings, and they processed it. So when we see here with this the static structure analysis, the deformation was reduced from 18.33 to 8.78 millimeter. And further, what they did is an ANSYS again performed with a stiffener occupying the full span. So initially, it was not the full span of the stiffness were not applied for the full span of the wing. So they did it with the full span. So with an increase of stiffener length, the deflection is reduced to further to 6.65 millimeter. The mass of the wing reduced to 1.7 kgs as compared to 3.5 kgs for wing with aluminum, the initial one. And the results stated that 0 and 90 orientation ply offers better safety against failure conditions as the reinforce more effectively takes up the load. Okay. And apart from this, the ply orientation for different angles were also carried out, and we can see the results for the different orientations of the ply. So if you see for 30, 60, 90 and 0 degree orientation, there is no improvement with the ply setup, and the deflection has enlarged throughout the wing as compared to the tip of the wing. When compared to 30, 60 and 90, results show that deflection came around 8.5 millimeter, which is still in the permission limit. And with 0 and 90 ply orientation, we can observe that the deflection were 1.15 millimeter higher when compared to the previous ply orientation that we did, that was 0 and it's a 90 and 0 degrees. Now coming to the cross plies, so cross plies were also studied, and if you can see here the constant thickness of 2 mm, again from the 10 mm thing they came down to 2 mm now, the thickness of the plies. Right, so and for different orientations it was checked, and we can see the deflections which are mentioned here in millimeters. for the cross plies. And the buckling analysis is also done for both the materials. And as the studies even state that, right, carbon fiber is far better, gives in better properties than e-glass. And the main intention was to try to see that if carbon fiber or e-glass can be compared with carbon fiber and depending on the requirements. But as far as missile wing is concerned, carbon fiber could be selected here. And if you see carbon fiber has a higher strength, it could bear the load with a minimum deflection and the buckling failure condition also improve significantly. And this was the factor there. So coming to the conclusions, the thickness of the wing has been reduced to 2.5 millimeter for surface panels and 1.5 millimeter for stiffness. The orientation like 90, 45, minus 45, 45 and 0. This was good orientation, better strength to give better strength to the wing. Then as the stiffness length increases, like we increase the stiffness length to the edges, the deflection reduced to 6.65 millimeter and the mass also the mass of the wing reduced to 1.7 kgs. The cross ply indeed had better load withstanding capabilities as the fiber has better directional properties. And as we have seen, the reduction in mass was there for e-glass. It was 61.7%. So the initial aluminum one was like 3.5 kgs and it reduced to 1.34 kgs. And when we use like carbon epoxy, it reduced to 7.3 kgs. Right? Sorry, from 3.5 to 0.968 kgs. And 60 to 45%, 45 degrees orientation plies were responsible for bearing maximum amount of load, whereas 0 and 90 degrees plies helps in maintaining the structural integrity. So I give this credit to my student, who has done an extensive work with a limited period of time. He has just joined the company and he couldn't come up here. So he asked us to present his work. So all credits goes to him. Thank you. If you have any questions or how it is like. Just wanted to mention it was a far extensive work and I wanted to incorporate it in a small, like the restrictions which we had. He has done much of with all the orientations he has done it. And finally has concluded like which orientation of the fly and the thickness of the fly is was good. And it was submitted to them.
Fix to the timings exactly within 8 minutes you completed. First of all, good luck for that. And as you already mentioned, I had the same question like in your presentation. Maybe because of the number of slides or time constraint, you may not have shown the details like geometry and mesh. You could have shown how they have designed the geometry and what are the dimensions and the meshing details were explaining, but you could have shown us in the PPT.
Exactly. That's why initially it's
Probably in your paper you must have.
So we can't get the data, the model data, the dimensions, we can't get it.
Okay, fine,
So
fine.
we can get only the results which we could present.
Okay,
Which we could incorporate in the thesis.
fine. Thank you.
Actually, we could mention all the data, but it's confidential.
Okay, okay. Understand, understand. No problem. Thank you. Thank you.
Does anyone want to ask any more questions regarding the paper? Thank you, sir. Now I would like to invite Mr. Sadanandam, sir, for presenting a paper on optimization of process parameters for fabricating AI aluminum 6065 surface composites reinforced with TIC via friction stir processing.
Good afternoon, one and all. Respected Chief Guest, Nitin Mittal sir. Today I presented my paper optimization of process parameters of fabricating aluminum 6065 surface composites reinforced with titanium tungsten, titanium carbide, and titanium borate via friction stir processing. So basically, the paper it includes friction stir processing. Before that, it becomes a friction stir welding. The major difference between your welding and your processing. Now your welding, we are joining of two materials or two different or same materials with the help of your by applying some heat and rotating the tool speed. Now the processing quite different, but here the processing we are modify the microstructure and surface characteristics of materials while including some reinforcing materials. Here we are including some reinforcing materials, titanium carbide, titanium borate, and tungsten. So now why the three nanoparticles in the sense, based on your literature review, major work done only titanium borate, but here we are so I reinforcing the material with the help of your tungsten, titanium carbide, and titanium borate. The uh, uh, major work in this your here the chemical compositions we are adding to your base materials, the magnesium, silicon, carbon, zinc, titanium, manganese, chromium. Apart this one, we are adding some nanoparticles of your surface. Why the basic is your nanoparticles? Your I adding titanium and tungsten, titanium borate. The major here, the major principle of your sorry here here we are reinforcing the materials with some 1 mm or 2 mm deep groove. In the deep groove, we are reinforcing the nanoparticles. By adding nanoparticles in the surface composites, we are changing their, we are processing their composite surface composites by applying some nanoparticles. By applying some reinforcement particles in the surface, then we are find out some mechanical properties. The processing of your nanoparticles, simply one line statement is your to improve their mechanical properties and their mechanical properties in terms of your corrosion resistance, in terms of your surface hardness, in terms of your heat treatability. You know. So that we are adding. After that, finding out some mechanical tests, so mechanical properties, we are optimizing the results with the help of some your optimization techniques. That optimization techniques I adopt is your ANOVA. So ANOVA or your Taguchi approach, that while applying your Taguchi approach, we are comparing the material with your manual as well as your optimization process. By optimization and your manual process, we can find out which one is best by adding your nanoparticles that where paper shows. Here the measure is your the major diagram, it represents your representation of friction stir welding with the help of your processing. The diagrams we did, located in NIT Warangal. So now here number of passes. Also the surface hardness or processing parameters, it depends upon your number of passes. While from first pass to second pass to third pass, increasing their properties. While while approaching your Taguchi method, here Taguchi method, these are the process parameters. So high rotational speed with the help of your 900, 1100 and 1400 with the composition of your 2%, 4%, 8%, 10% or 12% based on your requirement. But here we'll take as a 8%, 6%, 4%. That 8%, 6%, 4% based on our literature review, we are adding volume percentage of titanium carbide, volume percentage of tungsten. First, I consider titanium carbide and tungsten with a percentage of your 8, 6 and 4. Find out some mechanical properties. Then go with your optimization process. In that optimization process, we can find out some regression equations. in the regression equations, which one is your better, then we can find out from your optimal solution. These are the major conclusion of your my paper. So here it shows some results. These are some process parameters of your friction state processing or methods. So tool transfer speed, tool axial force, tool tilt angle, tool profiles. So here tool profile taper with thread. Some of the tool profiles here we represent as your here some straight taper and your taper with threaded. So here, so different pin profiles with different shoulders. So based on that shoulders, we can reinforcing the materials and to enhance their surface properties and process their parameters with the help of your tin profiles. Finally, I conclude that based on your based on results here, the sum of the mechanical properties, uh, micro hardness, ultimate tensile strength, yield strength, percentage of elongation, and wear rate. These are the mechanical properties I find out from your different mechanical tests, reinforcing with the particles of some of the cases it may be your titanium carbide and tungsten, and some of the cases I took as a titanium carbide and titanium boride, and titanium carbide with your tungsten with some minimum amount of nanoparticles reinforcing the based on their percentage of volume. Now here, these are the, here it represents your main orthogonal array. So I took as a L9 orthogonal array with respect to their percentage of composition. Here it represents your 9 represents L9. So now some of the cases it may L27 or L37. So here I took as a L9 based on my literature review, based on so here A, B, C that represents 1, 1, 1. It represents your tool speed. 2, 2, 2 that it represents as your percentage of volume. Then percentage of some volume percentage of nanoparticles. Now here it represents orthogonal array with a combination of titanium carbide and tungsten with some RPM 900, RPM 1100, 1120 and 1400 with volume percentage of titanium carbide tungsten, volume percentage of your tungsten with the help of your all, it's some varying volume percentage of compositions, varying with your RPM and reinforcing the two different nanoparticles varying with your RPM. Then find out some mechanical properties. Then we can comparing with the help of your optimizing process. So here some of your mechanical properties results with the help of your base metal, then composite materials. Here the final conclusion, better the value 95 or 90 above coefficient of relation, the volume percent is your better. That optimization process, it represents comparison between your manual as well as your optimization process. If it is based on your based on a regression equation, the percentage 95 and above, the value is good for your test as well as your whatever the composition we added to the material, the surface composites your better above if we get above the value of 95%. So is some extension cases. These are my presentations.
Any queries, sir?
Yeah. My question is like you have took L9, right? Isn't it? L9 with the help of three different percentages. So when you are taking three different percentages, what is the parameter you have considered for taking three different parameters?
So three different parameters based on our literature review. So most of the cases, L9 is the basic parameter to get ANOVA
No,
or Taguchi
it is
approach.
not basic L9. So when you have a Taguchi, when you're going with the Taguchi, the factors like 3 by 3,
3 by
3 by 3, isn't it?
3
3
by
by 3, it's L27. Generally, you get. We wanted to optimize it and you got it with L9, isn't it? Antena? And as you are talking about the literature, mentioning that it is from the literature. So as it is, you have took it from the literature, or you wanted to modify anything, or you have done it.
As per literature, I modify the only nanoparticles. Nanoparticles with the help of your percentage of volume. So most of the literature it gone through 2%, 4%, and 6%. But here I took as a 8%, 6%, and 10%. So based on that, some basic I took as based on our convenient. I go with your L9.
But what about this agglomeration parameter? How you have controlled it?
Agglomeration control. It one second.
Agglomeration.
So agglomeration mainly control with your processing of your parameters, controlling with your some of the that means whatever volume percentage.
At what level agglomeration can be controlled among the three parameters? 6, 8, 10 you have took it. So which one you find that it is better in mechanical properties?
So most of my cases, this sorry, that regression level, this value, this percentage was 8%. 8% of volume, but here not mentioned here.
No.
But volume percentage is 8. That is your quotient of relation. Now here I mentioned all the models statically significant 80, 95% of your confidence level.
Yes.
Sir, do you have any questions, sir? No, no. That's fine. Okay, thank you.
There comes our first session ending. We will break for lunch. Before that, I sincerely thank Dr. Mutel sir for his patient listening and valuable insights, sir. Thank you. And now let us break for lunch at the D Block canteen. After that, our student Kriya volunteers will be guiding you for the visit of CRDM lab. Please visit our CRDM facility at the parking, right? Thank you, sir. And we will assemble here again by 3:15. Yes, sir. 315. Yes, sir. By 2:30, please be there at CRDM facility. Our student volunteers will be guiding you there. Thank you.
ఆఫ్టర్నూన్ స్టూడెంట్స్ ఇస్తారు. చాలే
అది డ్రైవర్ ప్రాబ్లం బ్యాటరీ
నేను ఇక్కడ ఆపరేట్ చేస్తున్నా ఒకసారి కరెక్ట్గా వస్తుంది అన్ని లాగౌట్ చేయాలి ఇక్కడ అందుకే ఏంటిది నా మీద ఓకేనా